Hi guys, welcome to video lecture 3, Air Masses and Weather Fronts. As you take notes on today's video, be sure to keep your unit plan close at hand. The learning objectives will help you pick out the most important information. For each weather front, be sure to draw the symbol and note the weather during the passage of the front, when it's moving through, and after the front has passed. Go ahead and pause the video and record the essential question in your notes. An air mass can be huge, as big as the size of a continent, and can be thought of almost as being on a global level. Temperature and moisture content are nearly the same throughout an entire air mass. Air masses tend to take on the characteristics of the surfaces below them. For example, when an air mass forms over an ocean like these two, water evaporates into the atmosphere and the air becomes more moist. When an air mass forms over land, like these two, the air is typically dry. Air masses that form over the warm surfaces of tropical latitudes down by the equator tend to be warmer than those that form nearer to the poles. So air masses can take on a combination of characteristics. They can be cool or warm, dry or moist. Typical air masses that form and affect weather patterns in the United States are shown on this map below. Air masses that form over ocean surfaces are called maritime, and the ones that form over land surfaces are called continental on this map. This continental polar air mass over here contains cool, dry air, whereas the maritime tropical air mass down here contains warm, moist air. It's the motion of these air masses that cause most cold fronts to move from the northwest of the United States eastward across the country, and most warm fronts to begin in the southeast and move north across our country. More on weather fronts in a moment. First, let's take a look at some of the characteristics of high and low pressure air masses. A low pressure area or air mass has lower pressure because the atmosphere above is less dense. Low pressure areas tend to be warmer than the surrounding air masses. Less dense, low-pressure systems are represented on weather maps with a capital L, like this. Sometimes they're red. Think about a convection current. Air is pulled into a low-pressure area and lifts higher into the atmosphere. When the air rises to higher altitudes, it begins to cool off. Low-pressure systems in the northern hemisphere have a counterclockwise circulation pattern. The cooling causes any moisture in the air to condense and form clouds, possibly creating precipitation. Low-pressure areas are associated with stormy weather conditions. The more moisture in the air that spirals upward in a low-pressure system, the more likely it is that precipitation will occur as rain, sleet, or snow. Hurricanes, as pictured in this satellite image, are the perfect example of an extremely low-pressure system that causes dramatic amounts of rainfall. A high-pressure area has more air pressure because the atmosphere above it is denser. Dense, high-pressure systems are represented on weather maps with a capital H. Air sinks in high-pressure areas and spreads out slowly. The spreading air tend to move towards neighboring areas of lower pressure. Remember, all fluids move from higher pressure areas to lower pressure areas. High pressure areas are associated with fair weather or nice weather and mostly clear skies. In this satellite view of Texas, you can clearly see the high pressure system. There's an absence of cloud coverage compared to the lower pressure areas surrounding it. Most high pressure systems are large and move slowly. High-pressure systems in the northern hemisphere have a clockwise rotation. The boundaries between air masses are called fronts. Weather conditions can get pretty interesting at weather fronts due to the interactions between different temperatures, pressures, and moisture contents of the two air masses. There are four kinds of fronts. When a denser, cooler air mass pushes a warmer air mass, the boundary is called a cold front. Cold fronts are usually fast-moving weather fronts and push the warmer, less dense air up quickly to higher altitudes where it cools off and the moisture condenses, producing heavy cloud cover and short but intense rainfall until the front passes. Notice the heavy cloud band right here, this line in the satellite image, and the corresponding map symbol line on the outline map. The map symbol for a cold front is a blue line with triangles. Think of icicles. And the triangles point towards the direction of the front movement. So this cold front is moving towards the southeast. Here's a diagram that shows how the air masses interact during the passage of a cold front a little more closely. Notice that as colder, denser air rushes in, it pushes warmer, less dense air above it. Warm air is able to hold a lot of water vapor, but as it's pushed upward and cools off quickly, the water in the cooling air condenses, causing large storm clouds and intense rain or snow, depending on the temperature. The storms are only along the weather front, though, so once the cold front has passed, there is a high-pressure air mass behind it, causing clear skies, and you have dry, cool weather. When a warm air mass pushes a dense, cooler air mass, the boundary is called a warm front. A warm front moves much more slowly than a cold front. At the boundary, the warm air slides slowly up and over the dense, cool air to higher altitudes where it cools off and the moisture present condenses, often producing light scattered clouds and showers. Weather conditions may remain cloudy with scattered precipitation for several days due to these slow-moving fronts. Notice the scattered cloud bands in the satellite image and the corresponding map symbol line on the outline map. The map symbol is a red line with half circles, and the circles point, just like the cold front, toward the direction of the front movement. I like to think of the half circles as like little half-rising suns that bring warmth. So this warm front is moving east. Here's the cross-section of our warm front. Remember, warm fronts move more slowly. Instead of being pushed up by incoming cold air, warm air slowly rises above receding cold air. Since it isn't pushed up really fast, the cloud coverage and precipitation are less extreme. After a warm front is passed, the weather can be pretty gross. It's warmer, which tends to make the air more humid, and usually the skies remain cloudy and overcast. As the name implies, stationary fronts typically do not move one way or the other. To be stationary means to not be moving. The two air masses stall, and at the boundary line where the warm and cool air meet, moisture in the warm air mass condenses, causing precipitation and cloud cover. These conditions can remain in place for several days until one of the two air masses begins to move forward. The following weather, after the front is passed, will depend on which air mass, the warm one or the cold one, moves into your area. The map symbol is a blue and red line with alternating half circles and triangles on opposite sides of the line. It's a combination of the warm and cold front, and they're pointed in opposite directions to show that the stationary front is not moving in either direction. An occluded front is the most complicated of the four types of weather boundaries. Warm, moist air becomes trapped between two cooler air masses. Since the warm air is less dense, it rises and the two cooler air masses move in underneath. The moisture in the warm air masses cools and condenses at higher altitudes, producing clouds and precipitation. When you have storms that drop a ton of snow in the northeastern parts of the country, it's usually due to the passage of an occluded front. The map symbol for an occluded front is a purple line with alternating half circles and triangles on the same side of the line, and they point towards the direction of the weather front movement. Thanks for watching.